Chebyshev's theorem states the proportion of values from a data set that will fall within k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is the number of greater than 1. All right, so proportion of values from a data set that will fall within k standard deviations of the mean will be at least that number, using that formula, 1 minus 1 over k squared. All right, so if I let k be 2, that would be 1 minus 2 squared is 4, 1 minus 1/4. And that's 0.75 or 75%. So within 2 standard deviations, we can expect to have 75% of our data points. All right, 3 standard deviations, that would be 1 minus 1 over 3 squared, which is 1/9. And that is 88.8889, or about 89% of our data points. So if my mean is here, I'm just putting it there. My mean is there. Within 2 standard deviations, I can expect to have within 2, this is mu plus 2 standard deviations, and this is mu minus 2 standard deviations. I can expect to have 75% of my data points. Within 3 standard deviations, I can expect to have 89%. Now, this theorem can be used no matter what shape your data is in. Now, we have a stronger rule that we'll cover in the next video. But let's do some examples of the Chebyshev. So, the mean price of houses in a certain neighborhood is 50,000. And the standard deviation is 10,000. So mu is 50. And the standard deviation is 10. Find the price range for which at least 75% of the houses will fall. Well, it doesn't tell me what shape my data is, but it gives me at least 75%. Find the price range. The mean is 50,000. Find the lower value, upper value, where at least 75% of the houses will fall. Well, 75% using Chebyshev corresponds to 2 standard deviations. Remember, 1 minus 1 over k squared, 1 minus 1/4 is 0.75. So if you take the mean and go 2 standard deviations, and the standard deviation is 10,000, this gives me, is that too many zeros? No. That's going to be 50 plus or minus 20,000. So that gives me 50,000. Let me erase that. 50,000 plus or minus 20,000. So 50,000 minus 20,000 is 30,000. Would be the lower end number, and the upper end would be 50,000 plus 20,000, and that would be 70,000. And that's using Chebyshev. This next example, survey of local companies found that the mean amount of travel allowance for couriers was 25 cents per mile. So mu is 0.25. The standard deviation is 0.02. Use Chebyshev theorem. Find the minimum percentage of the data values that will fall between 0.20 and 0.30. Well, we need to find that difference. 30 cents minus 25 cents is 0.05. Okay? So we know the lower value and the upper value. We're finding the difference. And now we're going to divide that by the standard deviation. So 0.05 divided by 0.02 is 2.25. So what I found is my standard deviation, my K, how many standard deviations. So now I do 1 minus 1 over K squared, which is 1 minus 1 over 2.5 squared. Use your calculator and you get 0.84. So what we can draw from that is at least 84% of the data values will fall between 20 cents and 30 cents.